All right, I'm going to run you through how to calculate total resistance, total current, the voltage across each component in a series circuit, and then we're going to check our work by seeing if our voltage drops add up to the total voltage in the circuit. And so the first thing we're going to calculate is total resistance. And so for a series circuit, the total resistance is just equal to the resistance of component 1 plus component 2 plus component 3 and so on. And so for our circuit here, the total resistance is going to be equal to the resistance at 1 plus resistance at component 2 plus the resistance at component 3. Resistance at 1 is 220 ohms. Resistance of 2, 470 ohms. The resistance of 3, we have a different unit now. It says 1.2 k ohms. And so if we look at our conversion chart on our formula sheet, K is kilo, and so that is 10 to the 3. And so we know if we want to add these numbers together, they have to be in the same unit, so that if we move the decimal 3 places to the right, we will have 1200 ohms. So 1.2 kilo ohms is equal to 1200 ohms. You add these things up, and we get, let's do it, 220 plus 470 plus 1200. And we get a number in the thousands, it's 1890. And so the proper way to express that number would be to convert it into k ohms. And to do that, again, kilo is 10 to the 3. We're going to move it 3 places to the left this time. And so we're just going to round that to 1.9 k ohms. That's total resistance. The next thing we're going to calculate is the current, the total current. In a series circuit, the current is always constant. And so the current will not change in this series circuit. So it doesn't matter if I measure the current here, if I measure it here, here, or here. It's always going to be the same. And so that's just one of the rules that we have to understand about a series circuit. If we look at the formula that we're going to use, we are going to just use Ohm's law to calculate the total current. And so we're going to manipulate this V equals IR formula to get it the way we want it to solve for current. So to do that, we need to solve for I. So total current is going to be equal to the voltage total divided by the resistance total. The total voltage in our system is 12 volts. We know that by looking right here, the power source, it tells us the total voltage is 12 volts. We're going to divide that by the total resistance. We got the total resistance up here in the first step, 1.9 k ohms. Divide 12, and you get 6.3. And the unit that we're in, to cross out, to go straight across, 10 to the 3 is k ohms, 10 to the negative 3 is milli. And so the unit for current is amps, and so we have 6.3 milliamps. All right. The next thing we're going to do is calculate the voltage across each component. So in a series circuit, the voltage at each one of these components is going to be equal to the total voltage. All right? So again, we'll use Ohm's law. So the voltage at component 1 is equal to the current at component 1 times the resistance at component 1. The current at component 1, again, is 6.3 milliamps times the resistance at component 1, 220 ohms. We multiply those two things, 6.3 times 220, and we get 1,386. If we move the decimal 3 places to the left, we get about 1.4 volts. Because this is in milliamps, we have to convert it back to the standard unit. So we're doing that at our answer. So we convert that 1,300, move the decimal 3 places, and you have 1.4, about 1.4 volts. So if we need to get calculate the voltage at component 2, again, it's equal to the current at 2 times the resistance at 2. The current in a series circuit is always constant, so 6.3 milliamps times the resistance, 470 ohms. 6.3 times 470, 2,961. So if we round that, move the decimal 3 places, we're just going to round it to 3 volts. The voltage at component 3, again, is equal to the current at 3 times the resistance at 3, 6.3 milliamps times the resistance of 1.2 k ohms. 6.3 times 1.2. 6.3 times 1.2. We get about 7.6, we'll round it volts. And notice this time that because this milliamp and k ohm, because those cancel each other out, 10 to the 3 and 10 to the negative 3, we don't have to convert anything. Our answer is already in the voltage unit. All right, so now we can check our work by calculating the total voltage. The total voltage is going to be equal to the voltage at component 1 plus the voltage at component 2 plus the voltage at component 3. So if we input our 12 volts, which are total voltage, the rest of these three should add up to that. So voltage 1 was 1.4, voltage 2, 3.0, voltage 3, 7.6. If we do that, 7.6 plus 3 plus 1.4, we get 12 volts equals 12 volts. All right, so those are the basic calculations that you'll need to understand for a series circuit.